solve some problems based on osmotic pasteurized solutions. So the question is, the 1% mass by volume cases solution is ionized to the extent to 82%. What would be its osmotic pressure at 18 degrees centigrade? So we can use the formula of pi equal to C into S into T. So C is the concentration of solution and solution constant temperature. So we can find here, we require here I also, I because I KCl we need to find because it is 82% dissociated. So KCl is 82% dissociated, this will be K plus Cl minus. So we can find here alpha, this will be your 1 minus alpha at equilibrium. So I equal to 1 minus alpha plus alpha, this will cancel, this will be your 1 plus alpha, and alpha is given here how much, 82. So total will be your 1.82. so this is the I we know that, and divide by total. So total is I by 1, total is 1. This is the 1 means initial concentration is 1. So 1 is given here. So what is osmotic pressure? So concentration, so 1% means 1% is very clear, this is 1 gram in 100 ml of solution. Okay, so we can put here so this is N by V, so weight is given 1, okay, and molar mass KCl, so KCl molar mass is 74.5 gram, 39, and this is 35.5, so this is your 74.5 gram, and solution constant is 0.0821, temperature is 18 degrees, so it will be your 291, and multiplied by I equal to 1.82. so this is the whole equation. So this multiplied by 1.82. So you can write here properly, 124.5.0821 multiplied by 291 multiplied by 1.82. Okay, so on solving you will get here 3.21. This is whole value is 3.21, and this is your 1.82. So we will get answer here 5.842 atmospheric pressure. So this is the answers. So arrange osmotic pressure of a given solution in increasing order, assuming complete ionization of each salt. So there are salts given, glucose, potassium nitrate, K2SO4, K3PO4. These are the salts given over here. So we have to find out. So this one, so what is the osmotic pressure? So each we have to find out. So normality they have given, so we have to convert into molarity, and we know that normality is equal to molarity to N factor. So N factor of glucose is 1, KNO3 will be also 1, K2SO4 will be 2, and K3PO4 will be 3. So we have to multiply as accordingly. If you take molarity of glucose, so normality of glucose, so molarity of glucose means N factor by, so this will be your molarity is equal to N by N factor. So we have to multiply each by N factor. So molarity is given 1 divided by 1, so we will get here 1 molarity. Similarly, molarity of KNO3 will be here, so molarity given 0.1, so divide by 1, this will be your again 0.1. So molarity of this one K2SO4, we want to find out K2SO4, so this is given here 0.1, but here N factor will be 2, so answer will be your 0.05. And again molarity of K3PO4 we need to find out, so here molarity is here, normality is given 1, but N factor will be 3. This is, so answer here will be 0.33. So now it is very easy to solve it. So pi of glucose, okay, that is proportional to concentration of the glucose, that is how much, 0.1, and there is a ionization also given. So ionization I will be how much, glucose is 1, so we can write here, so here 1, so 1 is nothing but the I we are putting very I. So this is 1 value. So if you take full value, this will be your 1, you can see 1 by 1, potassium nitrate, so this is your 0.1 multiplied by this is 2, so I will be here 2, so okay, so this is answer is 0.1, but this will be your 0.2. You will take pi of potassium sulfate, okay, so this will be your potassium sulfate is 0.05, but multiplied by, so this is a 3 value. So here I equal to how much value, 3 value, so because 2 potassium and 1 sulfate, 3 is there, so 0.05 into 3, so this will be your 0 1 5 15. Then potassium of next is your K3PO4. So we can see here I equal to 3 plus 1, 4 value is there. So we can write here proportional to, so 4 is there. So the pi is molarity how much? 0.33. So this is your sorry, this is not 0.3, this is your 0.33. So this is your 0.33. Okay, so this will be answer here multiplied by 4. So here you will get answers 0.132. Okay, so we can compare here. So this is the highest, and followed by 0.2, followed by 0.15, then K3PO4, and last is the glucose. So we can write here. So pi of KNO3 is greater than pi of potassium sulfate, and this is again greater than pi of K3PO4. Again this is greater than pi of glucose. So this is our base result. This is the arrangement of the osmotic pressure according to the ionization of the solution. Again, so we will see here. So in this, calculate the osmotic pressure of DC normal solution of barium chloride at 27 degrees centigrade, showing 80% degree of ionizations. So again, it is a simple problem. So we can see here, right here, pi equal to same is there, n by V into S into T. So n by V is nothing but the concentration. So again we can see here, this is barium chloride, and DC normal they have given 1 by 10. DC normal means 1 by 10 normal of barium chloride. So we can see here, this is the 1 ion, this is the 2 ion. So 2 plus 3 means we are getting 3 ions we are getting here. Okay, here is 2 ions. So we can write here like this is also BaCl2. So it is undergoing ionization, Ba plus and 2Cl minus. This is alpha, this is the 2 alpha at equilibrium I am speaking. So this will be your 1 minus alpha. So total I will be your, initially 1 will be 0, this is 0. So 1 minus alpha plus alpha, this is your 2 alpha. The total will be your, this is cancelled, 1 plus 2 alpha. And alpha is already given, that is how much, this is the 80% is 0.8. So total will be 1 plus 2 into 0.8. So this will be your 1 plus 1.16, 16, 1 plus 8, total will be 2.6. This is the total given, 2.6 is given here. So now if you solve it here, come to this side. If you solve it here, so n they have given here, DC normal they have given, so 1 by 10. So this is the n factor is 2. So again we know that molarity is equal to, so molarity is equal to normality by 2. So this is how much we will get in by 2. So normality is 1 by 20 into 2. So this will be 1 by 20. This is given. So we put here value 1 by 20, and so moles is given here. So again this is the concentration of the solutions, and S is 0.0 atmospheric pressure, so 0.0821. So multiplied by temperature is 27 degrees centigrade. So this will be your 273 plus 27. So on solving, so we'll get here 1.2315 atmospheric, 1.2 atmospheric pressure. This is the given here, atmospheric pressure. So this pressure is nothing but the pi observed pressure, means experimental pressure we are getting, because we are multiplying with the, no, sorry, this is not observed, this is pi is the normal, this is the normal pressure we are getting. So 1.2315, this is normal. So what is the observed experimental? So pi by experimental is equal to pi by normal. So this is equal to 1 plus 2 alpha. 1.2 alpha we know that it is nothing but the 2.6. So again pi by experimental, so pi normal we know that. So pi normal means you multiply it 1.2315 into 2.6. So you will get here 3.2 atmospheric pressure. We can see, so experimental osmotic pressure is greater than the normal osmotic pressure. So this dissolution of any electrolyte, it increases how much process pressures, abnormalities increases. So this we have to take in. This is also a theoretical point of view very important. Now 0.1 molar aqueous solution of weak acids HA and HB shows the osmotic pressure equal to 0.3 atmospheric pressure and 0.3 atmospheric pressure respectively at 25 degrees centigrade. So calculate the ratio of their degree of ionization. So here we have two cases. Case 1 when we have pressure 0.3 atmospheric pressure and second is 0.35 atmospheric pressure. So we will take each case for each thing. Suppose for weak acid HA. So we can write here pi 1 equal to C1 into by T1, because T1 pi 1 is varying. So again we can solve this value. Pi they have been 0.3 atmospheric pressure, so you can put here 0.3 equal to this is your concentration is how much, 0.01 multiplied by 0.0821, and temperature is given here 25 degrees centigrade. So 273 plus 25 degrees centigrade, so it will be your so you put here, because I have taken answers here 27, put here 27. So 273 plus 27, so we will get here 300. So this is the answer here. So if you solve this value, again we have to put there ACCS, you have to put here alpha, so you have to put here I. In this case we can put here 1 plus alpha 1. Okay, now next is your, so on solving here we will get alpha equal to how much, 0.218. This I have calculated this value, that's why, because already I have solved this value. So if you calculate it, already we know every value, so it is very easy to calculate alpha here. Again from second acid, that is HB. If you take HB over here, so again you put same value, pi equal to again we have concentration is C1, same concentration, solution is also same, and temperature is also same. So here I will be also same, but temperature is different. Okay, atmospheric pressure different. Okay, so I will be again, this will be changing as per the pressure will be this one, alpha will also change according to the different pressure. So it depends on the pressures. So now what is this one? So here pi is given 0.35 and concentration is same 0.1, osmotic pressure is 0.0821, but here temperature will be that is nothing but the 273 plus 27. Okay, but here 1 plus alpha 2. Okay, because why, pi is changing, so pi change, so this will also change. So on solving here we will get alpha is equal to 0.421. So this is the alpha is there, alpha 2. Okay, now we can therefore find what is the ratio of the degree of dissociation. So definitely alpha 1 by alpha 2. So here we can put here 0.218 divided by 0.421. So on solving you will get here 0.52. So this is the actually degree of dissociation, ratio to dissociation of two different aqueous solution. Now a solution of complex at chromium chloride dot 6 molecules of water having coordination number 6 shows an osmotic pressure 73.89 atm at 300 Kelvin. When 1 molar solution of complex is used, 1 liter of this solution on treatment with excess of silver nitrate solution, which alpha is called, alpha is already given, it gives what moles of AgCl is formed. Means if you take 1 liter of these solutions and react with the AgNO3, means Ag will react with the solutions and they will give you AgCl. So what moles of AgCl is reacting? This means Ag is reacting with the Cl which is obtained from the complex CrCl3. Okay, so what moles of Cl is coming is equal to moles of AgCl. That is the only answer. So we have to find out. So again, first we have to find out how many I is there. So I will give the number of moles. So pi is equal to, so CRT into I. So this is the basic things. If you know I, we can get the solution. So this is 73.89 and concentration is given here 1 molar, so right here 1, and this is 0.0821 and temperature is again given 300 Kelvin. Okay, and multiplied by I. So if you solve it here, I will get 3. 3 means 3 ions we are getting from the CrCl3. So there may be possibilities. We can write here Cr H2O whole 5 and then 1 Cl inside. Okay, so 1 Cl inside and 2 Cl outside. and dot H2O. So if this you can break into, because 3 means 1 is this one, 2 is this one, so 2 plus 1, 3 possibility. So this will come out like CrH2O whole 5 Cl plus 2 Cl minus. So definitely this will be I equal to here how much, 3. So now we can say that for 2 moles of Cl we require 2 moles of AgCl. So this is the basically answer. So same 2 moles will completely react with the silver nitrate and they will give silver chloride in 1 liter of solution, because alpha is equal to 1. So this is the question. The slope of pi versus C was made against insulin concentration C in gram per ml and temperature 27 degrees centigrade. So if C is in gram per liter, so they are asking here gram per ml, but here C is in gram per liter, so you have to take care. 2 things are given, and the slope of line obtained is 4.65 into 10 power minus 3 gram per ml. What is the molar mass of insulin? So this is a question of some mathematics, some slope you have to find out, pi versus C. So pi is there, C is there, so we have to find out what is the basically slope. So some graph will be something like that. This is the pi, this is the C, and we have to find some slope. Maybe it starts from the here, maybe anywhere it can start it. Okay, maybe here it can start, here can start. So we have to find this, the slope. What is the slope of this graph? So write the formula. So formula is pi equal to CRT. Okay, pi equal to CRT, and we can break pi into this in this form, C in gram per ml. Okay, and this is your so we can write here pi C gram per ml. So it will be your concentration. So we can write here gram per ml. So N by V you can write here, or N by V is the concentration. So we can write here RT by gram per ml. So concentration is gram per ml. So we can write here C equal to N by V into RT. Okay, or we can also write W by V into RT by M. So W by V give you your concentration. Okay, so here we can find here pi versus concentration. So this is your concentration. Okay, so pi is equal to concentration in gram per ml into RT by M. Okay, so this is pi versus C is given here. So RT is become your slope. So slope will become your RT by capital M. RT by capital M. So they have given slope over here in gram per liter. They have given, this is gram per ml this is gram per ml. So we have to multiply by liter to convert ml into liter. So this slope is given 4.65 into 10 to the power minus 3 gram per ml. So you convert into gram per liter. So divided by 1000. So this will be gram per liter. And again R is given. So R is 0.082 and temperature is 27. So 273 plus 27. So this is the total temperature. And they are asking the molar mass. So molar mass will be here. If we solve it, so we will get here 5.3 into 10 to the power 6 gram. So this is the basically answer. So this is the one question based on graph. Okay, this is the question one based on graph. This we can easily understand it. So again questions, easy questions is there. At 17 degrees centigrade, calculate the osmotic pressure of 10% urea solutions. Solution content is 0.0821 liter atmosphere per Kelvin per mole and molecular mass is 60. So here urea solution is given weight by volume percent, means 10 gram in 100 ml of urea. So what is the calculated osmotic pressure? So again simple. So pi is equal to C into S into T. So we can write again modified form, pi equal to pi into V equal to so N into S into T. Okay, so this we can see that pi we have to find out. So volume is given here, so we can write here moles is given, so mole it is given, moles is 10 by 60. This is the total moles, and solution is 0.0821, and temperature is, temperature they have given 17 degrees centigrade, so 273 plus 17. Okay, so this is 290. Okay, and volume they have given 100 ml. So again we have to divide by 1000. So here write by 1000. Okay, so now problem is solved. So if you solve it, so you will get 39.68 atm. So this problem is not that much difficult, easy. Okay. At 20 degrees centigrade, the osmotic pressure of urea solution is 400 millimeter. Pressure is given. The solution is diluted and temperature raised to 35 degrees centigrade. When the osmotic pressure is found to be 105.3 millimeter, calculate the extent of dilution. It is very clear. You see, initial pressure of the urea, initial osmotic pressure was 400. Now this pressure is, after increasing temperature, 105.3 ml. So we are having two cases. So first we will take pi into V equal to N into S into temperature. So we have to take each case is case 1. So case 1, the first case is pi is different here. You can see here. So pi is, so you can write here pi is 400 by 760, and volume. So volume right here V1, extend dilution means first volume was different, and after the increasing temperature volume will be again different. So again moles right here, moles equal to S into this will be your temperature 20 degrees centigrade. So 273 plus 20. Okay, so this will be your 293. So this is the first case. Now second, case 2. So case 2 will be same 105.3 divided by 760. Now this time volume will be different because we are diluting. Then moles will be again same. You see, because we are diluting, so concentration of the solid will not change, it will be same, but volume will change, and S is again same. Again temperature is 273. Now it is increased to 35 degrees centigrade. So right here 35. So now V1 by V2. So we will have this ratio. So on solving, we can write here 2. So we can write here dividing 1 by 2 simply. So if you divide it, we get V1 by V2 equal to 293 divided by 308. So again this will be, if you divide it, this will be cancelled. So this will be your 105.3 divided by 400. So here it is very simple. Volume you will get, so it is almost coming on this ratio. So calculate the osmotic pressure of the solution obtained by mixing 100 ml of 3.4 solutions m by v of urea. This whose molecular mass this much, and 100 ml of 1.6 per solution m by v of cane sugar. Molecular mass is 342 at 23 centigrade. So two solutions, one is urea, one is cane sugar is given, one we are mixing. So we know that pi is additive. Pi is also additive. Okay, pi is additive. Boiling point, everything is additive. If you make any non-volatile solid, so in freezing point, in boiling point, on osmotic pressure, everything is additive. So it will increase, decrease, anything can be happen in the solution. So we can write here pi into V, and then we can write here moles of urea plus moles of glucose multiplied by S multiplied by T. Okay, so very simple. Now we can solve it. So pi is, we have to find out, volume is mixing 100 plus 100 ml. So we can write here, this is 100 plus 200, and so volume is given 1000. Okay, and moles of urea we know that, so moles of 3.4, so 3.4 divided by molar mass of urea. Okay, and plus glucose is given, so So 1.6, so 1.6 divided by 342. Okay, so this is for urea, this is for glucose, and solution constant we know very well, 0.821, and temperature is 20 degrees centigrade. So 273 plus 20. So formula is very simple. Now calculation starts. So on solving, you will get here 7.38 atmospheric pressure. So calculation I am not doing, because calculation part you can solve it. So you will get answer. It is taking only too much time. So basic area is how to solve the problem, how to understand the problem, and what steps we will take it to get the result. So if our steps is very correct, then we will get proper result, correct results.